Hello everyone, welcome back to my channel. I am student of Sri Venkateshwara College of Engineering. My name is A. Purnaseshan, Department of Information Science and Engineering. Today the main topic of our presentation is volume by triple integration and center of gravity. First let us see the introduction to triple integration. Triple integration is a mathematical technique used to calculate the volume of complex three-dimensional objects. The center of gravity, also known as the centroid, is the point where the object is perfectly balanced. Understanding these concepts is crucial in various fields such as physics, engineering and architecture. Volume by triple integration. Triple integration involves integrating a function over a three-dimensional region to find its volume. The process requires breaking down the region into infinitesimally small parts and integrating each part. The volume can be calculated by integrating the function over the limits of the region in three different directions, that is x, y and z. Steps for calculating volume. Identify the limits of integration for each variable for that is x, y and z based on the region's boundaries. Step 2. Determine the function that represents the volume of the object. Step 3. Perform triple integration by integrating the function over the specified limits for each variable. Triple integration formulas. So let us see the volume for Cartesian form. Triple integration dx, dy, dz and also double integration z, dy, dx. Now volume in polar form formula is 2 pi r square sin theta dr d theta. So for first question is find the volume generated by the cardioid. R is equal to of 1 plus cos theta above the initial line. Given r is equal to of 1 plus cos theta. We know that volume in polar form is double integration 2 pi r square sin theta d theta. So this is a formula for volume in polar form. Therefore, V is equals. Now let us draw a rough diagram of a cardioid. Let us share the above region. So this is the area of the region above the initial line. R is equal to A of 1 plus cos theta. So the limits of R varies from 0 to A of 1 plus cos theta. And the limits of theta varies from 0 to pi. As the straight line angle is 180 degree, so it is represented by pi. Pi is nothing but 180 degree. Volume is equal to double integration 2 pi r square sin theta dr d theta. First let us integrate with respect to r. So r varies from 0 to a of 1 plus cos theta and theta varies from 0 to pi. Let us write the equation once more. V is equal to integration 0 to pi integration 0 to a of 1 plus cos theta 2 pi r square sin theta dr d theta. Where first let us integrate with respect to r. That's why 2 pi r cube by 3 sin theta d theta. So integration of r square is nothing but r cube by 3. Now let us reshuffle the equation. V is equal to 0 to pi 2 pi sin theta by 3 r cube integrating limits 0 to a of 1 plus cos theta d theta. Now let us take 2 pi by 3 outside as 2 pi by 3 is constant. V is equal to 2 pi by 3 0 to pi sin theta and let us replace the values of r. First upper limit minus lower limit. So r cube by replacing r cube in terms of a of 1 plus cos theta and replacing r cube in terms of 0. Next let's use substitution. That is, let 1 plus cos theta is equal to t. Now by differentiating with respect to theta, so 1 becomes 0 because it is constant, and cos theta will become minus sin theta, and t will become dt. So by reshuffling it, by sending sin to the right hand side, sin theta d theta is equals to minus dt. While taking substitution, we need to even change the limits. So at theta is equals to 0. So 1 will be as it is, 1 plus cos 0 equal to t, where cos 0 is nothing but 1. So 1 plus 1 equals to t, therefore t is equals to 2. At theta is equals to pi, 1 remains the same, 1 plus cos pi is equal to t. So cos 180 degree is minus 1. So 1 plus of minus 1 equals to t, that is nothing but 0. So the lower limit is 0, upper limit is, no, the lower limit is 2, upper limit is 0. So volume is equal to 2 pi by 3, integration limits 2 to 0, a cube, let us take a cube of t cube dt. Let us take a cube outside as it is constant. 2 pi a cube by 3, 2 to 0, t cube dt. That's nothing but 2 pi a cube by 3. Integration of t cube is nothing but t to the power of 4 by 4. Sorry, t to the power of 4 by 4, not 8. Limits are 2 and 0. So volume is equals to 2 pi a cube by 3. Integration by substituting the integration limit, upper limit minus lower limit. So 2 pi a cube by 3, 0 minus 2 to the power of 4 by 4. So v is equals to 2 pi a cube by 3. We have forgot to substitute minus dt. So by substituting minus, so inner minus and outer minus will get cancelled. Therefore v is equals to 2 pi a cube by 3, 2 to the power of 4 by 4. So cancelling 2 1s are 2 2s are, v is equals to 16 pi a cube by 6. So 2 8s are 16 and 2 3s are 6. By cancelling, their final answer is v is equals to 8 pi a cube by 3 cubic unit. So the unit for volume is nothing but cubic unit. So let us see one more question in Cartesian form. Find the volume of tetrahedron bounded by the planes x equal to 0, y equal to 0, z equal to 0, and x by a plus y by p plus z by c equal to 1. So we know the volume. We know that formula for Cartesian form is v is equals to double integration z dy dx, or triple integration dx dz dy dx. So let us use the formula double integration z dy dx. It is as per your wish. You can use any one of the both. So let us draw the graph of tetrahedron. This is the graph of tetrahedron. At y-axis x and z will be 0. At x-axis y and z will be 0. At z-axis x and y will be 0. If z is equal to 0, then send everything to the right side. Z is equal to c of 1 minus x by a, y by b. Next, to find y, keep z equal to 0. So substituting z equal to 0, y is equal to 0 to y is equal to b of 1 minus x by a. Next, to find x, let z equal to 0 and y equal to 0. So x varies from 0 to a. So finally v is equals to 0 to a, x is equals to 0 to a, and y is equals to 0 to 1 minus b into 1 minus x by a, c into 1 minus x by a, y by a, dy dx. So first let us integrate with respect to y. So c is constant, so I am bringing it outside. So integration limits x varies from 0 to a and y varies from 0 to 1 minus x by a. Left out is 1 minus x by a minus y by a dy dx. So let us integrate with respect to y. V is equals to c into integrating limit x equals to 0 to a. So integration of 1 is nothing but y, and x by a is nothing but xy by a, and y is nothing but y square by 2b. And the limits are 0 to b of 1 minus x by a. Therefore, v is equal to, in place of y, substitute upper limits and lower limits. So b into 1 minus x by a minus x into b into 1 minus x by a minus b square by 2 into 1 minus x by a whole square. So let us simplify this. V is equal to c into 0 to a b minus bx by a minus xb by a plus x square b by a square minus b square by 2b into 1 plus x square by a square minus 2x by a. So this is the abbreviation. Now v is equals to c into integrating limit 0 to a b minus bx by a minus xb by a plus x square by b by a, x square b by a square. Now let us remove the brackets and multiply b by 2a, b by 2 inside the brackets. So b by 2 minus bx square by a square plus 2bx by a. Now this b and this b, it is in the form of 1 minus 1 by 2. So 1 minus 1 by 2 is nothing but 1. Even this is same. Minus bx by a minus bx by a. So it can be written as minus 2bx by a. So v is equal to c into integrating limit 0 to a. So 1 minus 1 by 2 is nothing but 1. So b minus b by 2 is nothing but b by 2 minus 2bx by a, and rest all as it is, plus x square b by a square minus bx square by a square plus 2bx by 2a. Okay, plus 2bx by 2a. Okay. Next, v is equals to c into integrating limit 0 to a. So b by 2 is as it is, and minus 2bx by a, and 2bx by 2a, and x square b by a square minus bx square by 2a square. It is in the form of 1 minus 1 by 2. So b by 2 minus xb by a, 2bx by a plus 2bx by a will come out to be xb by a plus x square b by a square minus bx square by 2a square is nothing but, is in the form of 1 minus 1 by 2, so it's nothing but 1 by 2 x square b by 2x square dx. So finally, integrating with respect to x, v is equal to c into, replace wherever x is there, integrate wherever x is there, integrate with respect to x. If x is not there, just add x. V is equal to c into xb by 2 minus x square b by 2a plus x square integration is nothing but x cube by 3. So x is cube by b by 6a square. And by substituting the limits, upper limits and lower limits, c into ab by 2 minus a square b by 2a plus a cube b by 6a square. By cancelling the a square and a cube, final output is ab by 2 minus ab by 2 plus ab by 6. Cancel the plus ab and minus ab. Therefore, v is equal to abc by 6 cubic unit. This is our final answer. Center of gravity. Center of gravity is the point where the weight of an object is evenly distributed. It is the average position of all the individual particles that make up the object. For a three-dimensional object, the center of gravity is often referred to as the centroid. Determining the centroid. To find the centroid of three-dimensional object, we need to consider its mass distribution. The centroid can be calculated by finding the average position of all the individual particles' coordinates. For a continuous object, the centroid can be determined using triple integration. The formula for Centroid using triple integration is mx is equals to rho into integral limits a and b half into f of x whole square minus g of x whole square dx. Steps for calculating centroid. Step 1. Identify the limits of integration for each variable, that is x, y and z, based on the object's boundaries. Step 2. Determine the function that represents the mass distribution of the object. Step 3. Perform triple integration by integrating the function multiplied by the respective variables over the specified limits for each variable. Applications in physics. The concept of volume by triple integration is essential in physics for calculating the mass of irregularly shaped objects. The center of gravity is crucial in determining the stability and equilibrium of objects. These concepts are used in analyzing the movement of objects such as projectiles and rotating bodies. Application in engineering. Engineers use volume by triple integration to calculate the volume of complex structures such as buildings or bridges. The center of gravity is crucial in designing stable and balanced structures. These concepts are utilized in structural analysis and design to ensure safety and efficiency. Applications in architecture. Architects utilize volume by triple integration to calculate the volumes of irregularly shaped spaces, such as rooms, halls, or atriums. The center of gravity is considered in designing structures to ensure stability and balance. These concepts help architects create functional and aesthetically pleasing spaces. So therefore, the conclusion is volume by triple integration and the center of gravity plays vital roles in various fields. Calculating volume helps us understand the spatial properties of three-dimensional objects. Determining the centroid aids in analyzing stability and balance. So I hope you all have understood my presentation. If you have any queries, please comment. Thank you.